Hello. In this video, we are going to learn about rational roots of polynomials. First, let's review the factor theorem that we learned in a previous video. Factor theorem states a polynomial f of x has a factor x minus k if and only if f of k equals 0, or if the remainder is 0 when the polynomials are divided, then the divisor is a factor of the dividend. Remember, that means that we need to solve x minus k. We need to solve it for x. Whatever we get, we're going to plug that into the function, and then we're going to say, did we get 0, yes or no? If you did, then of course it is a factor. This was an example from the previous video. We had f of x equals 4x to the fourth minus 2x squared minus 2, and we solved x plus 1 equals 0, and that was negative 1. We plugged negative 1 into the function, and that gave us 0. So that meant that x plus 1 was a factor. We did the same thing with x minus 2, and it should have said x equals 2, and we plugged 2 into the function, and we got 54. Since that was not 0, we knew that x minus 2 was not a factor. We also need to review the rational zeros test from a previous video. It stated to determine all possible zeros, at first we had to pick our p. Our p was the constant, and we had to list all of its factors. Remember, the constant is the number that does not have a variable with it. We listed all of its factors. Then we figured out our q. We identified our q, which is the leading coefficient, and we listed all of its factors. And then we put all of our p's over all of our q's. And that's all we did with the rational zero test. We didn't go any farther with it. We just listed the possible zeros. Okay, now we have an example. We are going to determine all the possible roots of a polynomial. This is actually an example that we did in a previous video, but I want to review it with y'all. So the example was f of x equals 2x to the fourth minus 2x squared minus 4x minus 4. So the first thing we had to do was pick out our p, and our p is negative 4, and we're going to list all the factors of 4. So all the factors of 4, plus or minus 1, plus or minus 2, and plus or minus 4. Then we see that our leading coefficient is 2. So all the factors of 2 are plus or minus 1 and plus or minus 2. Now we know that we had to make our p over q, so we took all of our p's and put them over all of our q's. Our first q is 1, so we need to put 1, 2, and 4 all over 1. And then our second q is 2, so once again we need to put 1, 2, and 4 all over 2. Now, these simplify. Plus or minus 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 2 over 2 is 1, 4 over 2 is 2. So looking at this list and looking at the ones that, this whole list has multiples in it. Well, we want a concise list. We don't want to see 1 4 times. So narrowing it down, we see that these 4 are the individual roots. So all possible roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/2. So this is the same list that's on the left-hand side of the screen. It's just consolidated on the right-hand side of the screen. So that was the review of a previous video. Now we're going to look at doing the same thing, but actually finding the roots of this polynomial. We're going to start putting everything together. So first we need to look at our 18, our constant. So the factors of 18 are 1, 2, 3, 6, 9, and 18. Our leading coefficient is 1. So our only q is plus or minus 1. So all of our p's over our q's are just all of our p's already. 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, and 18 over 1 all simplify to those numbers. So we know that all possible zeros are 1, 2, 3, 6, 9, 18, the positive and the negative of both of those. Now, looking at what we learned in the last video, our possible positive real roots, you can just, I can't say this word right now, but Descartes, that's not correct, but that's what I'm saying right now. Rule, we're going to look for sign change. So f of x equals x to the fourth, that's positive, negative x cubed minus 11x squared plus 9x plus 18. X to the fourth is positive, x cubed is negative. Positive to negative is one sign change. Then negative x cubed to negative 11x squared is still negative, but a negative 11x squared to a positive 9x, that's our second sign change. So we know we have two real roots, or, possibly two positive real roots, or we possibly have 0 positive real roots, because 2 minus 2 is 0. Now we need to find our possible negative real roots. So we need to plug in negative x to all of these spots. So negative x to the fourth, that's an even power, so it's just going to be x to the fourth. Negative x cubed, that's an odd power, so the negative is going to make the negative in front of it positive. Negative x squared, that's even, it's just going to pretend you didn't even put it there. 9 times negative x is going to be negative 9x. So anytime you plug in a negative number into a negative x into an even power, it's not going to change anything. It's just going to act like you never even did it. But the odd powers are where we have to be careful because it is going to affect our sign. So analyzing this polynomial, we see positive x to the fourth, positive x cubed, no change there. Positive x cubed to a negative 11x squared, there is a change there. Negative 11x squared, negative 9x, no change. Negative 9x to a positive 18, there is a change. So once again, we have possibly two negative real roots, and then 2 minus 2 is 0. So we're either going to have 2 or none. Okay, let's figure out what our roots are going to be. Let's start plugging in positive numbers because they're the quickest to type into the calculator. So using the factor theorem, I'm going to plug 1 into the calculator. And my goal is to see if I get 0. When you type all of this in, do you get 0? No, you got 16. So 1 is not a factor. Let's move on to 2. We're going to plug 2 in. Did you get 0? Yes, you did. So we know that 2 is a factor. 2 is a root, is a 0, is a solution. Let's plug in 3. When you plugged that in your calculator, did you get 0? Yes, you did. Okay, we still have 6, 9, and 18, but is there any reason that we need to continue plugging in positive numbers? No, because we know that we can only have a maximum of 2 positive roots, and we found 2 positive roots. X equals 2 and x equals 3. So we're done plugging in positive. Now we can start plugging in negative numbers. So let's start with negative 1. Did you get 0? Yes, you did. So there's one of them. Now we're looking for one more. When you plug in negative 2, do you get 0? No. Negative 65, definitely not. What about whenever you plug in negative 3? Do you get 0? Yes, you do. So now we have found all 4 roots because x is negative 1 and negative 3. We knew that we needed 4 roots because the polynomial had the highest degree of 4. The degree matches the roots. So 4 roots, and we happen to find 4 real roots. In the future, we will learn how to find, if there are any roots that are not real, how to find those imaginary roots. So that concludes this video. Oh, there's the answers right there, all in a nice box. When you put them in, make sure you go least to greatest. -3, -1, 2, and 3. Now, this concludes the video.